Okay, this is part 4 of the Laney Klipp saga, shall we say, repair. Things didn't go quite to plan, even after all the work I've already mentioned. And with a brand new set of matched valves right the way through it, we had a problem with bias levels. This amp has a single negative bias trimmer here. Put the red end on it here, and adjust the bias on these 4 output valves. They either all go up or they all go down. There's no individual adjustments. With the brand new set, I had 3 which were within quite close tolerances of each other, fully acceptable, and 1 which rose by an added 9 milliamps above the others, which was not acceptable, obviously. I sent that back and got a replacement from the supplier. The one that came back still was rising 6 to 7 milliamps above the others. So I had a situation where you couldn't get what I would consider an acceptable balance on the bias. 2 to 3 milliamps difference between all 4 from the highest to the lowest is a typical figure, or less, even better. So I had a quandary. What was I going to do? You can go a long-winded way about this and fit individual negative bias sets to everyone, but it's a lot of faffing about, and there's not much room left on this circuit board, on this turret board. So I had an idea I would try something else, but before I did that, I decided I'd make sure the bias network was good. I replaced the bias negative diode with a brand new one. As I told you, I've already sorted out the trimmer and everything like this. The long tail pair and the 220Ks all replaced for the phase inverter and onwards. As already mentioned, the screen resistors and grid resistors all been replaced. Also, I checked all the wiring, make sure everything was correct, and no shorts or anything like this, open circuits or whatever. So I had this problem. So I conferred with somebody who's a very knowledgeable chap, and I decided to go ahead with an unusual setup. Was to add to the grid biasing network, add cathode biasing. So we then have a hybrid biasing system, grid biasing and cathode biasing. As the first 3 here were all acceptable within range, matched wise, I only had this one to deal with. You could put the same system on all 4 if you wanted to, but in this instance there was no, and it's very cramped in here, so there was no need to. So I had this one on the end here. What I've done here, if you can see it, I screwed and soldered a Bakelite terminal strip, just 2 sections here. This orange wire is the cathode ground. That is connected to pin 8 and pin 1, which are tied together, suppressor and cathode. I then ran, after various tests to make sure I got the correct balance on the bias, a 75 ohm 2 watt resistor to the terminal strip and connected the cable there, and it brought the bias within 1 milliamp of the rest, which was absolutely great. So now I have 4 output valves that are operating well within tolerances, which is great. So that is excellent. It's been a long-winded process. There's over 50 different new parts in this amp. Many hours of work and head scratching, particularly the head scratching. I've already tested it, it works fine. So now it's going to go back in its cabinet, and then I'll be on the phone to the chap who owns it, and we'll take it from there. It's been a bit of an experience, this one, but these challenges are what make it interesting, even if it does raise your blood pressure. Anyway, ta-ra.